Welcome back to the Deep Dive. Today we are strapping in for a look at the future of how AI doesn't just, talk to us, but how it actually operates our digital world. We are looking far beyond chatbots and diving into something called TARS, which is a really cutting-edge, open-source AI agent stack.
It really is.
Our sources today are the documentation and repository notes for the ByteDance UI TARS stack. And let's be clear. This isn't just some prototype.
Not at all.
This is a highly active, highly watched repository. I mean, it's boasting over 21.3 thousand stars, which, that tells you the community sees massive potential here.
Yeah, that's a huge signal.
So our mission today is to unpack this entire structure, understand what a GI agent actually does, and figure out why it's being hailed as the shortcut to human-like task completion.
And that phrase, human-like, that's really the critical insight we need to start with.
Okay.
Historically, AI agents have been great at text generation or, using APIs, application programming interfaces.
Right, calling a service.
Exactly. But a multimodal AI agent stack, like TARS, it connects advanced AI models, your LLMs and your vision models, with the specific infrastructure needed to execute complex, real-world tasks.
No, it's the bridge.
It is. And the key differentiator for TARS is this intense focus on the GUI, the graphical user interface, and its ability to visually recognize, understand, and navigate a screen. It doesn't just read code. It actually sees your desktop.
Okay, let's unpack that immediately because the sources show TARS isn't just one thing. It's a stack, and it includes two main projects. For you, our listener, trying to get a handle on this ecosystem, what are they and how do we differentiate between them?
That's a really important distinction because they serve different deployment needs. You've got two main products here.
Got it.
First, there is Agent TARS. And you should think of this as the foundational, general, multimodal AI agent stack.
The toolkit.
The toolkit, that's a perfect way to put it. Its goal is broad, bringing the power of this GUI agent and vision into any environment, your terminal, your entire computer, a browser, or even integrated into another product.
So it's flexible.
Super flexible. It primarily ships with a command line interface and a web UI, which makes it really modular for developers and integrators.
So Agent TARS is that framework for integration. What about the other half of the coin?
That would be UI TARS Desktop. This is the fully dedicated desktop application. It's designed for the end user who just wants to run the agent locally.
The out-of-the-box solution.
Exactly. It provides a native GUI agent specifically focused on your local operating system. And this version is driven by a specific set of optimized models, the UI TARS and the Seed series models, and it ships with these powerful local and remote operators built right in.
I think the best way to grasp the power of Agent TARS especially is through its promise of that human-like workflow. We're not talking about simple tasks here.
No, not at all.
The source material highlights these tasks that require context management, comparison, and pulling in external data.
Yeah.
For instance, one of the showcase instructions is, please help me book the earliest flight from San Jose to New York on September 1st and the last return flight on September 6th on Priceline.
Right.
Now, that's easy for a person, but for an agent, that means navigating dynamic web forms, reading availability tables, and clicking on elements based on time and price.
It's complex.
Or consider the even more complex example they give. I am in Los Angeles from September 1st to September 6th with a budget of $5,000. Please help me book a Ritz-Carlton hotel closest to the airport on Booking.com and compile a transportation guide for me.
Wow.
I mean, that shows the agent isn't just clicking around on a site. It's dynamically managing a budget, it's filtering search results based on a brand and distance, and then it's seamlessly compiling secondary info from somewhere else entirely.
That's the real leap right there. It's performing synthesis and complex decision-making, all based on visual data. Precisely. And this is why this whole effort is so significant. It's not just a cool project. They actually cite the underlying academic paper.
Oh, interesting.
Yeah, it's called UI TARS, Pioneering Automated GUI Interaction with Native Agents. This tells you that ByteDance is treating this as fundamental research-driven automation. They're building on a scientifically grounded approach to visual control.
Okay, here's where we take the deep dive into the engine itself. The docs use a few key acronyms: MCP integration, event stream, hybrid browser agent. Walk us through the mechanisms that let it actually do those complex booking tasks.
Okay, so we really need to break down the three core mechanisms that make this whole thing work.
Let's do it.
Let's start with the multimodal foundation. Both TARS projects are powered by natural language control, which is driven by vision language models, the VLMs.
So that's non-negotiable.
It's the absolute core. The agent takes a screenshot of your active application or browser, and the VLM processes that image, identifying actionable elements, buttons, text fields, icons, and then it links them back to your natural language command. It's basically the AI's eyes and its visual brain.
So if a website redesigns its homepage tomorrow, the VLM just sees the change, kind of like a human would, and adapts.
It should, yes. And that actually brings us to the second point, hybrid control. Specifically, the hybrid browser agent within the core agent TARS stack.
Okay.
Most older automation tools rely on the document object model, the DOM, which is the underlying code structure. The problem is, if developers change the code element IDs, the automation just breaks.
Right. I've seen that a million times.
TARS solves this by using three strategies: pure GI agent, so visual clicks, pure DOM, which is code-based interaction, or a hybrid strategy that combines both.
But wait a minute, if it relies on the DOM and visual cues, isn't that just twice as much complexity? I mean, doesn't the hybrid approach introduce new ways for it to fail, even if it solves old ones?
That's a really critical question, but the robustness it provides actually outweighs the complexity. It creates resilience.
How so?
Well, think about it. If a visual element is covered up or hard to identify, the agent can fall back on the reliable DOM path. But on the other hand, if a developer hasn't labeled the DOM elements clearly, the agent can just use its visual understanding.
I see. It's a smart redundancy layer.
Exactly. This flexibility is what prevents the automation from constantly failing whenever a website pushes some small update. It makes the system robust enough for, enterprise-level use.
Okay, that makes sense.
Yep.
So let's look at the third major piece, MCP integration. This sounds like highly specialized infrastructure.
It is. MCP stands for the multimodal computing platform that the kernel is built on. So while the agent's VLM is doing the reasoning, the thinking, the MCP integration handles the execution of high-level actions. The doing, yeah. The system supports mounting what are called MCP servers, which connect to real-world tools.
Well, why is this specialized server necessary? Why can't the agent just, call a tool directly?
This fundamentally changes the security and operational profile of the AI.
Okay.
I mean, if the agent is told to book a flight, it needs access to your web session, your environment, maybe even financial details to complete the transaction.
Right, scary stuff.
The MCP server acts as a secured execution broker. The agent sends its intent and its action plan to the MCP server, and the server handles the secure execution and credential management. This ensures the AI's reasoning core is isolated from the sensitive actions it performs.
It's a huge insight. It transforms the AI from just a helper into a kind of automated, trusted operator.
That's the goal, which leads us to the last piece, the event stream.
Okay.
The event stream is effectively the agent's real-time memory and its consciousness. It's a protocol-driven data backbone that tracks every decision, every visual input, every action, and every response. And this is essential for what they call context engineering.
What does that mean in practice?
Think of it this way. When you are performing a complex task, you might pause, searching for a hotel, open a spreadsheet to check your budget, and then go back to the hotel booking page without losing your place. The event stream is what allows the TARS agent to do exactly the same thing. It tracks every click, every screen change, and every intermediate thought process. This continuous, detailed context is what allows it to pause the booking, check an external API via an MCP server, and then return to the exact right step on Priceline.
And that transparency is also great for developers or power users.
Right.
They can debug exactly why the AI made a certain choice.
Exactly.
So we understand this resilient hybrid engine. Now, let's see how ByteDance decided to package this power for, say, the average developer and the privacy-conscious user specifically in that UI TARS desktop application.
Right. The UI TARS desktop app is all about practical capability. Beyond being cross-platform, so it supports Windows, macOS, and the browser, the source material really emphasizes its security. It offers precise mouse and keyboard control while remaining private and secure because it features fully local processing.
And for a lot of people, keeping the AI brain and control mechanism entirely on their own machine, that's a massive benefit.
Huge.
Now, if we look at the timeline in the repository's news section, the development pace within 2025 is striking. I mean, this level of development in less than a year suggests ByteDance sees this as a top strategic priority.
It was absolutely a focused sprint. They launched the foundational UI TARS SDK in February 2025 for building agents.
Right.
By April, just 2 months later, they released the major v0.1.0 of the desktop app, which already featured the advanced UI TARS 1.5 model. But the true game changer arrived pretty quickly after that.
And that brings us to the crucial operational upgrade in the v0.2.0 release in June 2025.
Yes.
The remote computer operator and the remote browser operator.
Yes.
This is where the barrier to entry for widespread adoption just, poof, evaporated. The key detail here is that the documentation describes these operators as completely free and requiring no configuration.
No config, it's plug and play.
It's effectively plug-and-play remote or local control of any system. That immediately lowers the technical hurdle for any developer wanting to experiment.
And we can't overstate the power those operators introduce. If you look at the showcases for the UiTARS desktop, you see two really distinct but equally impressive levels of system control.
Go on.
Take the local operator example. Please help me open the autosave feature of VS Code and delay autosave operations for 500 milliseconds in the VS Code setting.
Okay, that sounds really mundane. Why is that revolutionary?
Because VS Code, a desktop application, doesn't offer a traditional API for changing nested settings like autosave timing. The agent has to use its VLM to visually recognize the settings gear icon, click it, type autosave into the search bar, identify the specific input box, and then precisely type the new value.
So it's doing it all with human-like mouse and keyboard dexterity.
Exactly. It's essentially mimicking human muscle memory and visual acuity to get around the normal limitations of the operating system. It's interacting with the UI on a level that was previously reserved only for us.
And then you contrast that with a remote operator.
Right. The example is, could you help me check the latest open issue of the UiTARS desktop project on GitHub?
So going out to the web.
Here, the agent is performing external web-based interaction. It requires navigation, reading dynamic web elements, retrieving information. Using visual cues and DOM data, it shows its full range, from micro adjustments in local settings to macro navigation on external websites.
That range of control, local, remote, visual, code-based, that's genuinely what defines a true general-purpose agent. And the most recent update, v0.3.0, from November 2025, that seems clearly geared toward the power user or the enterprise developer, someone who needs to integrate TARS into a production environment.
Yeah, they focus heavily on making the agent faster and more transparent. They introduce streaming support for multiple tools, including shell commands and these multi-file structured displays.
But the real insight for me comes from the focus on efficiency.
Yes, the runtime settings. They added timing statistics for tool calls and the agent's deep thinking steps.
And why does that timing statistic matter so much?
Because if the agent takes 10 seconds to click a button, that's completely unusable in a production environment. This focus on runtime stats shows ByteDance is prioritizing speed and efficiency for users who expect instant results.
And for debugging, they added the new event stream viewer.
Yes, which takes that data backbone we discussed earlier and turns it into a clear visual debugging tool. It's essential for data flow tracking. Plus, they added exclusive support for the AIO Agent Sandbox,
Which is for isolated tool execution.
a critical security and stability measure. It ensures that if an external tool execution fails or has a security vulnerability, it remains isolated from the core agent and your main operating system.
So, after all that, what does this all mean when we summarize the TARS stack? Where does this leave us?
It means that the TARS stack provides a robust, fully open source framework for building AI that interacts with software the way a human does.
Right.
It uses visual context and precise, adaptable controls across both local and remote environments. We are fundamentally moving beyond simple scripting and into, genuine, site-enabled machine operation.
And this democratization of GUI control powered by natural language, that's a really powerful development.
It is.
So for you listening, you now have the full context on this incredibly sophisticated stack that is driving GUI automation forward. This is sophisticated tech, it's moving at a breakneck pace, and it's open for anyone to inspect and contribute to.
And that leads to a final, maybe provocative thought for you to consider as you explore the field further.
Go for it.
Agent TARS is explicitly set up to support execution with high-end proprietary VLM models, like Anthropic's Claude 3.7 Sonnet, alongside specific Volsingen models. So, will the success of this open-source tool, which promises universal access to GUI automation, ultimately be controlled by the proprietary pricing and performance metrics of the few companies supplying the VLM brains it requires? Something to chew on as you watch the space evolve.